welcome to Science Friday on WAMU 88.5. Today we are here with world-renowned ecologist Dr. Klein, here to talk to us about population growth and population ecology. And Dr. Klein, what exactly is population ecology and how does one measure a population size?
So population ecology is the study of various factors that affect populations and how and why a population changes over time. And one of the main ways to measure population size is the Lincoln Index, otherwise known as capture, mark, release, recapture method. And so populations are usually too large for every individual to be counted, so that's why we use these estimating techniques. And so the Lincoln Index in particular is one of these techniques we utilize. The steps involve, the first step is capturing as many of the individuals in the area as possible. And then the second step is to mark all of those individuals that you first captured. This is the N1 value, which stands for the number of caught and marked initially in your sampling. The third step is to release all of the marked individuals and allow them to settle into their habitat, become more acclimated with their environment. So you're not just putting them down and bringing them back up. This also allows for them to get used to their environment. The fourth step is to recapture as many individuals as possible and count how many are marked and unmarked. This is the N2 value, the total number of caught on the second occasion. The fifth is to calculate the estimated population size, and we use the Lincoln Index formula, which is N1 times N2 divided by N3. So N1 is the number of caught and marked initially in your sampling population. And N2 is the total number caught on the second sample, and N3 is the number of marked individuals within that recapture, the second capture.
Okay, well, now we're going to go to a short commercial break, and afterwards we're going to go and talk to our field journalist, Sam Chisholm.
Thanks, Griff. I'm currently in my neighbor's backyard checking out all of this English ivy. This English ivy can be used as a rough example for population growth in a local ecosystem.
It looks like the ivy has undergone all three phases of the sigmoid curve and has now reached the plateau phase, which means that something is limiting the population, including a shortage of food, an increase in predators, or an increase in disease or parasites. And it has already gone the exponential phase when the population is growing at an unprecedented rate and is benefiting from a surplus of food and resources. It has also undergone the transitional phase, where the carrying capacity is being reached and the population growth is beginning to slow down. At the plateau phase, natality and mortality are about constant, and immigration and emigration are also about equal with each other.
All of this talk about ivy goes to show that nature is pretty neat.
Thank you, Sam, for that fascinating information on population growth. We are back here in the studio with Dr. Klein here to give us more information on the Lincoln Index.
So I have a student from Rockville High School, Helu, here to help us with a demonstration of the Lincoln Index. So ladies and gentlemen, today for the Lincoln Index we're using Legos. We cannot use real animals, obviously for safety reasons. So Helu, we're going to have you simulate the Lincoln Index, so close your eyes and grab as many Legos as you can. So how many Legos did you pick out?
10.
Alright, so 10 represents the N1 value. Alright, so there's 10 marked and 10 captured in the first capture. So this will simulate the mixing and the acclimation of organisms to their environment. So Helu, pick out another capture. How many is in that capture?
6.
Alright, so there are 6 in there. And how many were marked of those?
2 of those.
Alright, so we set up the equation. We have 10 initially caught. Then we put those back, and now we have 6 that were caught in total and 2 were marked. So that equals 60 divided by 2, which is 30. Now, before the show, we counted these out, and we do know that there are indeed 30 in this container. Therefore, this is an accurate estimation of the population size. Now we have some research provided to us from Helu on a real-life example of estimating population sizes.
And fisheries are a good real-life example of sampling population sizes. Getting reliable data on fish population size is hard because fish are a mobile species, and therefore population sampling techniques such as the capture, mark, recapture technique only work in small bodies of water. Since the Lincoln Index only works in small bodies of water, most population sizes of fish are estimated from fish catches. Population sampling of fish has led to restrictions on catching fish, bans on catching an endangered species, and closed seasons are declared.
Thank you, Helu, for that fascinating information, and thank you both for coming on the show. Well, it looks like that's all the time we have for today, folks. Thank you for joining us on this edition of Science Friday.